Today, lesson 51B, graphing linear equations. And so we're just extending on really the last lesson. In the last lesson, we graphed linear relationships that weren't necessarily proportional. Today we continue with that idea. So let's go ahead and get started. Here are some of the things that we have talked about. We talked about equations like this, where I had you fill in the table based on y equals 3x plus 3. And then we plotted those ordered pairs, scaled our axes, and went from there. And this, of course, is not proportional, but it is linear. And the initial value is right there at 3. And the unit rate is a rise of 3. We're rising 3 y's for every 1x all the way up the graph right there. Rising 3 y's for every 1x. And that's going to be very important for an idea that we talk about tomorrow. And then, of course, the initial value, which I already mentioned, is right there in the table, or it's right there on the graph. And that is when x is equal to 0, y is equal to 3. So we had some graphs that went uphill from left to right. And then we had some that went downhill from left to right, like this one. So we fill in our table based on y equals 14 minus 2x. Scaled our axes. Plotted the ordered pairs. And this one is going downhill from left to right. And in this one, we are basically dropping or decreasing 2 y's for every 1 positive x, all the way down the graph there, dropping 2 y's for every 1x. And that gives us our unit rate. And then our initial value is when x equals 0, y is equal to 14. You can see that in the table and on the graph, and that's our initial value. Okay? All right, I would like all of you to go ahead and do number 1 on the 1 quadrant axis, or coordinate plane. Don't do it on the 4 quadrant one yet. So we fill in our table when x is equal to 0, y is equal to 1, using y equals 2x plus 1. When x is 1, y is 3. When x is 2, y is 5. When x is 3, y is 7. When x is 4, y is 9. Now, there are some things that we should start to notice at this point. And I have, on purpose, I've not really mentioned it really at all, only showing you in terms of what the graph looks like. But look. If we look at the y values, notice that we are increasing by positive 2 there and increasing by positive 1 right there. Same thing here. We're increasing by adding 2, adding 1 to the x numbers. Adding 2 to the y numbers, adding 1 to the x numbers. Adding 2 to the y numbers, adding 1 to the x numbers. And if we did all of those ratios, it should be obvious to you that that numeric value of the ratios of the difference of y's over the difference of x's is 2, which is the numeric value of the unit rate. It's also, of course, this number right here, which also is the numeric value of the unit rate. In addition to that, every single time when we do these, this value right here is very important because that is the initial value. Well, if we look carefully also, that is always that right there. And we should start to recognize those sorts of patterns there. So going through here, we're going to graph this, and we will see clearly that it is linear. And the unit rate is a rise or increase of 2 y's for every 1x. And once again, I could show you clearly on the graph. We're rising 2 y's for every 1x. And that's all the way up the graph, rising 2 y's for every 1x. That also is another way of seeing that our unit rate is what it is. And the numeric value of that is found within the equation. Okay? And the initial value, of course, is on the graph, and it's in the table. When x is 0, y is 1. But we've been pretty much sticking with 1 quadrant this entire time. But in reality, in real life, we also see negative numbers. So in 6th grade, one of the things you worked on was plotting ordered pairs in a 4-quadrant system. So if we take this graph and now extend it to 4 quadrants, nothing really changes We just have 4 quadrants now, right? The difference, I guess, if you're plotting now is you go left or right first instead of always right, and then up or down. It just basically depends on what the x numbers are and the y numbers. So now let's go to that 4-quadrant system and graph that same set of ordered pairs, the values in our table. And the one thing we need to make sure we do now is we extend the line all the way through the coordinate plane. Don't stop at the dots, which is what a couple of you have been doing. Notice that my line goes all the way through the coordinate plane. And the reason is simple. There are more points or more ordered pairs that will work for us here. For example, here's one that will work for us, right? That's a perfect ordered pair. Here's another one that will work. Here's another one that will work. And we could go all the way. So that's the reason why we extend our line and put arrows at the end, because these things go on infinitely in both directions there, okay? And that sort of idea will probably help us later on in today's lesson, okay? All right, number 2. Let's go ahead and try that one. When x is 0, what would the y value be? Somebody tell me, please. What?
4.
Somebody said 4. Is that right?
Yes.
Okay. When x is 1, what is the y value? It's 1. Good. And remember, all we're really doing here, and I'll use for 1, when x is 1, we're basically evaluating that when x is 1. Negative 3 times 1 is negative 3. Negative 3 plus 4 is 1. All right, go ahead and finish that table. Plot your ordered pairs. And draw your line all the way through the coordinate plane. All right, when x is 2, y, of course, is negative 2. When x is 3, y is negative 5. When x is 4, y is negative 8. We draw our line all the way through the coordinate plane, and that's what your graph should look like. The unit rates, we should be able to see that in 2 different places. One, from the table, like I described in number 1. To get from 4 to 1, we are basically subtracting 3. To get from 0 to 1 on the x, in the x direction, we're adding 1. And that works all the way down the table. Subtract 3 to get from 1 to negative 2. Add 1. Subtract 3. Add 1. Subtract 3. Add 1. And if we did all of those ratios of the differences of y's over differences of x's, negative 3 over 1, they all simplify to negative 3. That also happens to be this value right here. Also, when we drop 3 or decrease 3 in the y direction, we go 1 in the positive x direction. And that's all the way. I'll do this down here so I'm not writing over myself here. Dropping 3, going 1 in the positive x direction right there. So you can find it in a number of places. Regardless of all of those different things, the unit rate is negative 3y for each x, or each 1x. And of course, the initial value is at 0, 4, so when x is 0, y is 4. Okay? All right, number 3, go ahead and graph y equals 5x minus 7. All right, when x is 0, y is negative 7. We can substitute those values in if we want to. X is 1, y is negative 2. X is 2, y is 3. X is 3, y is 8. And when x is 13, excuse me, x is 4, y is 13. One other thing I want to bring to your attention one more time is this. Looking at the y values, to get from here to here, we are adding 5. To get from here to here, we are adding 1. And when we check all of those ratios of the difference of y's over the difference in x's, we get 5, which happens to be the unit rate. Okay? All right. Draw our line all the way through. Unit rate is 5 y's for each 1x. initial value, of course, is when x is 0, y is negative 7. All right, back side of your notes. Here's what I want you to try and do. I want you to try and do, just do number 4, because I'm going to have to stop you, I guess, for number 5. All right, so I'm going to fill in the table when x is negative 3. All right, 0, y is negative 3. When x is 1, y is negative 5. You should be filling in the table, please. And one more comment. I'm noticing a couple of you not drawing your line all the way through the coordinate plane. You're stopping at the end of the dots. Please do not do that, because there are way more ordered pairs that satisfy this equation. Our unit rates, negative 2y for each positive 1x. And our initial value, of course, is when x is 0, y is negative 3. All right. This one, I, on purpose, to make a point, put the incorrect table as far as the x values. I put 0, 1, 2, 3, 4 in yours. I did that so to remind you. It can't be that, because, well, it could be that, but we'd have fractional values that we're supposed to plot. So can you please change the x values in your table to what they are up here? 0, 3, 6, 9, 12. Of course, they have to be that, or they don't have to be, but we want integer values for our y values because they are easier to graph. Okay, so using everything that we've talked about today, go ahead and graph this one, please. So we're using multiples of 3 for x. So when x is 0, y is negative 1. When x is 3, y is 1. When x is 6, y is 3. When x is 9, y is 5, and when x is 12, y is 7. Now, obviously, that one doesn't fit on our coordinate plane, and that's okay. We just won't plot that one. Draw our line all the way through the coordinate plane, like so. Our unit rate is 2/3 of a y for each x. Now, I want you to add to your notes. What we really have in terms of a rate instead of a unit rate, or is an unsimplified version of the unit rate, is we have 2 y's for each 3 x's. Right? To get from here, this is positive 2y. Oops. Positive 2y for each positive 3x. And the reason for thinking of it that way is going up 2/3 for every 1x, that's too hard to do when it's scaled by ones. Okay, so add this piece right here to your notes. That's going to become very important for the very last part of today's lesson. And then our initial value. When x is 0, y is negative 1. All right, everybody try number 6 very quickly. And then we'll compare with our shoulder partner, and then we'll talk about the last idea for today. Using multiple of 4 in the x column, because that is the denominator, we'll end up with integer values. And so the value should look something like that. And we draw our line all the way through. I was only able to fit a few on this coordinate plane. Our unit rate is really negative 3/4 of a y for each x, but that doesn't help us in terms of graphing quicker. Here's what helps us. Add this to your note, please. The rate of negative 3y for each 4x. Negative 3y for each 4x. And once again, that comes from this right here. Negative 3y for each positive 4x. And then our initial value, when x is 0, y is positive 5. So that's graphing in 4 quadrants. But as we've been doing in the last 2 or 3 lessons, we're now going to go backwards and try and come up with the equation for that line. First thing you should do is find the perfect order pairs, like we've done in the 1 quadrant problems. So I see one right there at 0, 1. That, of course, is the initial value. I see another one right there at 2, 2. I see another one at 4, 3. There are a lot of them. I usually say at least put 3. I don't know that you necessarily need more than that. So now we need to come up with the equation that represents that situation based on everything we've talked about today. I want you to think about it. And now turn to your shoulder partner and come up with what you think that equation is. Here is here. The rate going between point and point is a rise of 1y. Right here, 1y for every 2x. That's the rate. That, of course, is not the unit rate because that's not simplified. The unit rate would actually be 1/2 of a y for each x. And then the initial value, of course, is when x is 0, y is 1. All right, we've got 3 problems left. Please do all 3 with your shoulder partner. I'll get back to you in about 2 or 3 minutes. Same thing. Oops, hold on. I forgot to put the equation up there. We did already mention it, but it is y equals 1/2 x plus 1. All right, now, work with your shoulder partner on number 8, 9, and 10. Number 8. First, find perfect ordered pairs. I always start with the initial value, which is right there at 0, -2. You need at least 3, in my opinion. And so I'm going to go with those 3 right there. But I know there are some further down, like in quadrant number 4 from 6th grade. And so I went ahead and added another couple down there. You don't really need to post that many. Now the rate is -3y for each 5x. Because wherever you want to start, like here, I'm going to go 3 in the negative y direction and 5 in the positive x direction. If you went this direction, you'd be rising +3y and then going -5 in the x direction. But remember, -3/5 is the same thing as 3 over -5, regardless of that. And that leads us to a unit rate of -3/5 y for each x, -3 divided by 5. And we need that for the equation. The initial value is at when x is 0, y is -2, and so that gives us an equation that is y equals -3/5 x minus 2. Any questions? Number 8. And we're going to do the same thing for the other 2. Find some perfect ordered pairs, find the unit rate, find the initial value, put that together. All right, number 9, here are some perfect ordered pairs. The rate is 3 y's for each positive 7x. I'm not going to show it this time, but when you convert that to a unit rate, that's 3/7 of a y for each x. That's important, as well as the initial value, and that gives us y equals 3/7 x. Is this a proportional relationship, yes or no? Yeah, this one is, right? And then number 10, find the perfect order pairs, or some of them. The unit rate is 1y for each x. So is the rate, by the way. The initial value is when x is 0, y is -7. And we get y equals 1x minus 7 or y equals x minus 7. Any questions? All right, we are finished for today.